Hi everyone. So here is a basic training app what we can use with the UI. It is made with the Flask and PyTorch. So it provides two options for data sets. We can select MNS dataset or Fashion MNS dataset, and then we can train two models and compare the results of them. Before jumping on that, there are a couple of main features about this app. One is the dataset option. We can select from these dataset options. In future, we can provide other options or maybe even allow user to upload the dataset and process them. Then there is a memory management. So basically, since we are asking user to write a batch size in the UI, there is a chance that they can write a batch size which cannot fit in our memory, right? So we apply a dynamic logic here where we say that our 70% of system RAM is locked for training the models. And now when the user type a batch size, let's just say they are typing 15 as a batch size or 20 as a batch size, or maybe they can just type 23 as a batch size. Our main job is to first figure out, can this batch size be fit in my memory? If yes, is this number which is 23 or 15 or 20, are these numbers a power of 2, which is the popular batch size estimation as well, like 4, 8, 16, 32, 64, 128. So it's kind of we are keep on multiplying the numbers by 2 and we are following the batch size for better memory management, right? So we figure that out in our code dynamically and then we allocate the batch size. So let's move towards training here. First is the MNS data sets. We're going to pick this data set. Now you will see the second page, which is the configure model. So we need to configure two models here. So let's just configure both of them for two epochs. Here in the batch size, we can modify the batch size. So let's keep one batch size as 15 and another batch size as 20. We can also modify the learning rate, the optimizer, what we need to use. Let's keep Adam itself right now. The channel size also we can modify. For the faster training, let's keep the channel size as 2, but we can type any number here. Internally in the network, once we get the channel size, in the multiple layers, we are dividing this channel size. So basically the first layer will have the channel size was what user is writing, and then we follow it up with the multiply by 2, then multiply by 4, then multiply it by 8, and this way we'll follow this for a couple of layers, and then we're gonna create our complete network architecture. Now we're gonna click on start training and both of these models will start training. So this is the training page. As you can see, the training is initiated for both of these models here, and we can see the progress, the loss of the models, accuracy of the models, and what is the effective batch size. So for first model, we wrote batch size as 15. Now 15 cannot be our batch size according to the rule, so we make it 16. And same for the 20 as well. We end up by making it 32. And both of these numbers now can fit in our memory as well. We are able to take care of it. In case if a number is not fitting in our 70% of memory, we are going to apply gradient accumulation there. So that code is also available in the app. So in case if user is writing a very big batch size what we cannot fit, we will still follow this rule. We will calculate the best batch size number for them first. Even if it doesn't fit in our memory, we can use gradient accumulation and then train the model. Here are the plots, and this is where the training logs are going to come in. Now, once the epoch finishes, it is going to update the training logs here, and then it is going to update the logs here as well. So as you can see, now the first epoch is completed for model 2, and the numbers are here, 91, 75. And then same for this one also, loss. So the above one is for testing and the below one is for training. Now we can see here also the epoch 1 is successfully updated for both of these models, and now the model epoch 2 for model 1 is also initiated. Internally we are using threading, and then with the two threads we are initiating the training, and then for both of these models they can max use the 70% RAM of my system, and both of these models are running currently on CPU. That's why I did not write a very big channel size, otherwise it could take a lot of time to train the models itself. So we need to take care of that for this demo alone, but we can type a bigger channel size as well if you want. And now since the model 2 is completed for both the epochs, you can see the lines here in the plots, and same thing is going to happen for model 1 as well. And for model 2 we can see the details here about the training and testing. This part of the app, it always sends the hit to the API and it gets the request done. So that's why it will be blinking here, because it always try to hit in timeline and then gets the records if that is available in the data array what we have in the backend. Now since both of the models are completed, we can see the plots for both of these models, and then in the logs as well we can see the accuracy numbers directly in case if we don't want to see the plots. Now we can click on view model predictions, and here first we're going to show what user gave configuration for both of these models. So epochs were 2, then what was the batch size user gave us, what was the learning rate used, optimizer used, channel size used, and the dropout value used. And then in the we can select always from which set we want to evaluate. So let's just first evaluate with the training set. We'll get the predictions here. That's the exact comparison on the same image, that okay, which model works better for you, you can identify that. Now we can do the same thing for test set as well. We're going to click on view get predictions, and then it's going to show us for uh, get testing set.